Hey, welcome, and thanks for checking in on a little review coming up for our next test. I don't have a whole lot there on the prerequisites, but there's a little bit. So anyway, let's see how we do on the first three questions. This first one says, let's go ahead and solve this equation graphically. Now, my intent there is actually very, very simple. I just want you guys to be able to know how to use technology. This is way too hard of a problem to solve through any means other than a calculator. So what I intended you to do is just open up your calculator. I personally like to go to Y1 and set in the left side and Y2 and put in the right side. So I'm just going to call it equal to 6. I'm going to hit my math, and the number to the side is where they store the absolute value, and that's the absolute value of 6x minus 7. I need to hit my arrow to the right to get out of that first absolute value, and then enter a second absolute value. Now, these are weird equations. When you have two different absolute values, that creates some strange looking things. And I usually hit a zoom 6, which is a zoom standard, because I'm not sure what an intelligent window is, and I kind of hope for the best. And I'm looking for these two values where those things cross. And as it turns out, if I do second calculate or trace, and I move the cursor very close to that point of intersection, number 5. So I'm going to move my cursor close, and I hit enter 3 times. I get this nice little decimal of 0.571. Now, as it turns out, an interesting feature of the calculator is if I hit the second negative sign, that's the answer, and I hit math, enter, enter, it's going to turn the last thing it did into a fraction, which is going to be the fraction 4/7. So we could say x equals 0.5. Trying to remember exactly what that thing was. Let's see, let me go back here to calculate that intersection. Ding, ding, ding. 0.571, or we could say 4/7, which is a preferable answer. But there's another one. So when I do that again, and I go second calculate the intersection, I want to move over closer to that other intersection. And I can say, just like the previous one, we actually have a nice answer. It's x equals 2. So the two locations of those points of intersection are there. Now, for number 2, we wanted to know the domain. Now, I said every time you see a square root or something like that, you should have one. And so I know the number 5 is a significant number. I'm allowed to plug in 5 because I can take the square root of 0. I just can't divide by 0. But if I try to go to the right of 5, like 6, 7, 8, 10, 15, or 100, all of those values are good. So my domain is all values greater than or equal to 5, or if you'd like to, you could use interval notation and say from 5 to infinity. Those are both valid notations. In fact, this is all 3 notations here. But the range is a little bit tricky. So what I wanted you to do is just think about it a little bit. I know that generally the square root of x looks like this, and its range would be all values from 0 to infinity. But if we put that negative in front, it's going to flip it over. It's going to flip it over, and now the function is coming down. And so now instead of going from 0 to infinity, it's going from negative infinity up to 0. And then that 7 just bumped it up a little bit. So it turns out my range is all the y values are less than or equal to 7. See, the smallest, the biggest number that I can get out of this is 0. And because anything that I do that is above the number 5 is going to keep taking more and more and more away from that 7. And so I'm going to get all these values below 7. Now, as far as identifying things as linear, you want to remember that if functions are linear, they have that kind of shape. That means no matter where you stood on them, if you could imagine walking along this curve, the rise and run would be steady. That delta y over delta x, that steepness factor. So if I look at this one right here, my delta v is 9. My delta n is 3. This slope would be 3, okay? But if I look here, my rise is 5. This is 3. This is 7. this is 3. Well, it appears that I do not have a linear situation because this is not a constant rate of change. So this is not linear. The slope is not constant. But so let's take a look at the other one. And what I notice right here is every single time, let's see, it dropped 4, it dropped 4, it dropped 4. Every single time I do something, it appears that I drop 4, but right here it appears that I rise 4, right? I'm rising 4 every single time. So if I did my delta K over my delta P, which is really delta Y over delta X, right? My rise, you could think of these as the Y's and these as the X's. But my delta K over my delta P is -1. So it looks like my slope is every time -1. Now, this is kind of just, I just do this myself because it just feels better to me. I'm going to take this thing right here. Notice that 0 gives me 7. I just gave you the y-intercept. So if I said y equals mx plus b, I know that I have a slope of -1, and I have an intercept that if I plugged in 0, I got 7. The only problem is that's not what this problem says. It uses the letter P and K. So all of those X values, all of those inputs should be P's. And all those Y values, the outputs should be K. So we have K is equal to -B plus 7. And that will do for the first 3. I just decided to make this short since the next question is kind of long. Okay, I'll see you back later on. Hopefully that helps. Bye-bye.